Welcome viewers. In this video we'll see the solved problem based on the implementation of logical function using NAND gate only. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. Draw the logic circuit for the following function using only NAND gate. Need to draw the logical diagram using only NAND gate. The given function is f equal to a b c plus a bar b plus a c bar d bar. We need to implement this function using only NAND gate. There are 4 parameters available, a, b, c, d. First we'll see the input line. So this is the input line A. This line will give the input of A. In order to get the A bar, here one NAND gate is implemented here. Tapping is taken and one NAND gate is connected. The two inputs of the NAND gates are short circuited and common input is given. NAND gate with common input will act as a NOT gate. So that here we will get the A bar. This is the line A. From line A, the tapping is taken, that is given to the NAND gate. The NAND gate, both the inputs are short circuited, which is having the common input. That means it will act as a NOT gate. So here we will get the A bar. Then the line input line B is available. This blue color is the input line B. B bar is not required, so no need to draw that. Then the input line C is available. This green color is the C. In order to get the C bar, again one more NAND gate is connected with the common input. Two inputs are short circuited having the common input, so that we'll get the C bar. Then input line D is available. In order to get the D bar, again one more NAND gate is connected with the common input. Two inputs are common, so that we'll got the input of D bar, right? So we have A bar, and B, C bar, D and D bar. So these are all the inputs are available. In order to implement the function, we can go for the further design. So here we have A, B, C. For that we need one NAND gate, and A bar B, another NAND gate. Then A, C bar, D bar, another NAND gate. So we need 3 NAND gates, and add all these 3 functions, we need one more NAND gate. Now we'll see this function one by one. First we'll implement the function A, B, C, right? So that we have one NAND gate is available here. So the inputs are connected. A, B and C are connected together. The input to the NAND gate is A, B, C. So the output of NAND gate is nothing but A, B, C the whole bar, right? We will get this A, B, C the whole bar. The output of NAND gate is nothing but if the two inputs are given A, B, means the output will be A, B bar. Similarly, A, B, C means we will get A, B, C bar. Then the next function is A bar B, right? So the one more NAND gate is connected here and given with the input A bar and B, right? So that what we'll get, the output will be A bar B the whole bar, right? Like this, A bar B the whole bar, the output of the second NAND gate. And then we need one more NAND gate. In that it is connected with A, C bar and D bar. The third term is A, C bar and D bar, right? So this third NAND gate is connected with A, C bar and D bar. So what is the output of this NAND gate? We will get A, C bar, D bar the whole bar, like this, A, C bar, D bar the whole bar, right? So we have 3 NAND gate used. Based on that we got the output A, B, C the whole bar, A bar B the whole bar, A, C bar, D bar the whole bar. Again one more NAND gate is connected. In order to get the desired output, one more NAND gate is connected. So what will happen? These 3 inputs are multiplied and the complement is given, right? For example, AB means AB bar, like that. These 3 inputs are multiplied and we got the bar, whole bar. This whole bar is the output of this NAND gate, right? So 3 NAND gates produce these 3 outputs. This NAND gate produce multiplication of 3 output with a common bar, right? So finally what we got, A, B, C bar dot A bar B the whole bar dot A, C bar, D bar the whole bar to the whole bar, right? Now we'll see that whether we got the desired output. This is our desired output. we'll see that whether we got. So this A dot B dot C whole bar can be written as A bar plus B bar plus C bar based on the De Morgan's theorem, right? A dot B the whole bar equal to A bar plus B bar based on this the De Morgan's theorem. Here it is available A bar, B bar, C bar the whole bar can be written as A bar plus B bar plus C bar. So like that it is written. So A, B, C whole bar, already one bar is there to the whole bar. Then A bar, B the whole bar already available to the bar. Then plus A bar, A, C bar, D bar the bar to the whole bar, right? So now this expression is written like this based on the De Morgan's theorem. A dot B means it become A plus B, right? Here dot is available, now converted into plus. So the 2 bar double bar is available. So again it will give the normal value. A, B, C whole bar the whole bar. 2 bars are available. 2 complement means it will give normal A, B, C. Similarly, A bar B double bar means it is A bar B. Similarly here A, C bar, D bar, right? So this is our desired output. A, B, C plus A bar B plus A, C bar, D bar is our desired output. Now we implemented the digital logic circuit using only NAND gate and we got the desired output. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.